All right. This time I'll take integration, definite integration, NCERT exercise 7.8. Okay, we should do definite integrations, all the questions of NCERT exercise 7.8 along with the solved examples. We shall work out, okay, how to integrate a given function and evaluate the limits. Okay, that is definite integration, integrating a given function and evaluating the function at upper limit minus lower limit. We'll give the answer. There are two theorems here. One is the fundamental theorem of calculus. What is the definite integral given here? Integral from a to b f of x dx is called as definite integral. A is called as the lower limit and b is called as the upper limit of the integral. Okay. So what is definite integral, you must know. Okay. And the fundamental theorem of calculus we have. F be a function which is continuous in the closed interval ab, and this tells you to differentiate a definite integral d by dx of integral from a to x f of t dt is equal to f of x. Okay, so how to differentiate a definite integral? A is a constant here, t is the variable for integral. The variable for integral is t. So when you integrate and differentiate, integration and d by dx are reverse process of each other or inverse process of each other. They'll cancel out. Correct? So that's a fundamental theorem of calculus. So here a is the lower limit. No, lower limit is a constant and upper limit is x. That's a variable. For integration, no, the variable is t, but you are differentiating with respect to x. You are differentiating with respect to x, and upper limit is x. Correct? So you are differentiating a definite integral. So how to do is evaluate the function at upper limit f of x into derivative of x1, f of x into 1. So I'll show if you want. That is d by dx of, I'll write here itself, d by dx of integral from a to x f of t dt, correct? Integration and d by dx are going to cancel out. Evaluate the function at upper limit. So what we get? F of x into derivative of x. Derivative of x is 1 minus f of a into derivative of a. Derivative of a is 0. Correct? F of x into derivative of x1 minus lower limit. F of a, evaluate the function at lower limit. F of a into derivative of a is 0. So this part is 0. This part is 0. So what we get is f of x. That is what the fundamental theorem of integral calculus says. And more generally, we have Newton-Leibniz formula, very useful for competitive exams. I have given it here, how to differentiate a definite integral where lower limit and upper limit both are variables, both are functions of x. Lower limit is u of x and upper limit is v of x, f of t dt. So substitute the upper limit, f of v of x into derivative of v of x minus f of lower limit u of x, f of u of x into derivative of u of x, u dash of x. Like this we get. Evaluate the function at upper limit, differentiate the upper limit, minus evaluate the function at lower limit, differentiate the lower limit. So we get Newton-Leibniz formula. Okay, how to differentiate a definite integral where lower limit is function of x, upper limit is function of x. Okay, and this is a particular case of Newton-Leibniz, I can tell, because lower limit is constant there. Here lower limit, upper limit both are variables. Substitute the upper limit, in place of t put the upper limit v of x, f of v of x into derivative of v of x. Substitute the upper limit into differentiate the upper limit minus substitute the lower limit, differentiate the lower limit. That's called Newton-Leibniz formula. Okay, quite useful for competitive exams. And also we got one more theorem here. F be a function which is continuous on the closed interval ab, and capital F is the antiderivative of small f. So this tells you to integrate a definite integral from a to b. After integrating the function f of x, we get new function capital F of x. Evaluate the function upper limit minus lower limit. Correct? Given an integral like this, a to b f of x dx. Integrate the function f. After integrating the function f, we get capital F of x. Capital F of x. Evaluate the function at upper limit minus lower limit. F of b minus f of a. Correct? Evaluate the function at upper limit minus evaluate the function at lower limit. F of b minus f of a. After integrating a function small f, you get a new function. Call it as capital F. Capital F is antiderivative of small f. Okay. After integrating, evaluate the function at upper limit minus lower limit. You get the answer. Is that clear? So we shall take the problems based on this. Evaluate the following integrals. First one, take the integral as I is equal to integral from -1 to +1 x plus 1 dx. Integrate it and apply the limits. Get the answer. Evaluate the function upper limit minus lower limit. Okay. Integral of x is x square by 2. Integral of 1 is x. Limits from -1 to +1. Evaluate the function at upper limit minus lower limit. So this is equal to what? 1 by 2. X square by 2 means half into x square. Half into. Evaluate the function at upper limit. 1 square minus -1 square plus 1 minus 1. Correct? X square by 2 means half into x square. Half you keep outside. Evaluate the function at upper limit. 1 square minus -1 square. For this upper limit minus lower limit. -1 square is same as 1. Correct? 1 minus 1 is 0. This part is 0. Correct? So what do you get? 1 minus -1. 0 plus 2, which is equal to 2. X square by 2 means half into x square. Half you keep outside. X square. For x square put the upper limit minus lower limit. 1 square minus -1 square. 1 square is 1. Minus 1 square is 1. 1 minus 1, 0. 0 into half, 0. 1 minus -1. 1 plus 1, 2. 0 plus 2 is equal to 2. Clear? Move on to the next one. Integral of 1 by x limits from 2 to 3. Integral from 2 to 3, 1 by x dx. So given integral from 2 to 3, 1 by x dx. We know integral of 1 by x is log of mod x. Integral of 1 by x is log of mod x. Evaluate the function at upper limit minus lower limit. Log of mod x. Evaluate the function at upper limit. What do you get? Log of mod 3. Correct? Substitute the upper limit first. Log of mod 3 minus log of mod 2. Mod 3 is same as 3. Mod 2 is same as 2. Log a minus log b. Log a by b. Using property of log, I can write log of 3 by 2. Log of 3 by 2. Next one. Integrate this and apply limits. I is equal to integral from 1 to 2. What we have? 4x cube minus 5x square plus 6x plus 9. Integrate all of them. It's a polynomial function of degree 3 is given. Integrate each term with respect to x and evaluate the function at upper limit minus lower limit. 4 into integral of x cube is x power 4 divided by 4 minus 5 into integral of x square is x cube by 3 plus 6 into integral of x square by 2. Integral of 9 is 9x. Correct? Limits from 1 to 2. Limits from 1 to 2. Correct? 4 into integral of x cube x power 4 by 4. Constant keep as it is. Integral of x square x cube by 3. 6 into integral of x square by 2. Integral of 9 is 9x. 4 cancels. So what we get is x power 4 minus 5 by 3 into x cube. Correct? 6 by 2 is 3. 3x square plus 9x. For this entire thing, put the upper limit 2. Lower limit is 1. Correct? Put x equal to upper limit. What do you get? 2 power 4 minus 5 by 3 into 2 cube. Correct? Plus 3 into 2 square plus 9 into 2. Evaluate the function at upper limit. Minus evaluate the function at lower limit. Or else you can take each term and put upper limit minus lower limit. That also will do. Okay? Take each term. For that, there itself we can do upper limit minus lower limit. That method is also possible. Okay, that only will do better. We'll take each term and apply upper limit and lower limit there itself. That becomes easy for us. Okay. So x power 4 is there. For that you put upper limit minus lower limit. X equal to 2 minus x equal to 1. So what do you get? 2 power 4 minus 1 power 4 minus 5 by 3 into evaluate the function at upper limit minus lower limit plus 3 into 2 square minus 1 square plus 9 into 2 minus 1 correct? Evaluate the function at upper limit minus lower limit. 2 power 4 minus 1 power 4. 5 by 3 into 2 cube minus 1 cube. 3 into 2 square minus 1 square. 9 into 2 minus 1. 2 power 4, 16. 1 power 4, 1. 16 minus 1, 15. Here 2 cube 8. 8 minus 1, 7. 7 into 5, 35 divided by 3. 2 square 4. 4 minus 1, 3. 3 into 3 is 9. 2 minus 1 is 1. 1 into 9 is 9. 9 plus 9, 18. 18 plus 15, 33. 33 minus 35 by 3. Take common denominator 3. 33 is 33 by 1. 33 into 3, 99 minus 35, which is equal to 64 divided by 3. Move on to the next one. Integral of cos 2x, sin 2x, is it? Sorry, yeah. Integral of sin 2x. Take the integral as I. I is equal to integral from 0 to pi by 4 sin 2x. We know integral of sin is minus cos, correct? So integral of sin is minus cos 2x now, divided by coefficient of x, which is 2. Limits from 0 to pi by 4. Integral of sin is minus cos. Minus cos 2x divided by coefficient of x. Coefficient of x is 2. Integral of sin is minus cos. Minus cos 2x divided by coefficient of x 2. Correct? So this is equal to minus 1 by 2. Keep outside the integral. Evaluate the function at upper limit. Pi by 4 is upper limit. 2 into pi by 4 is pi by 2. Cos pi by 2 minus cos of 2 into 0. 2 into 0 is 0. Evaluate the function at upper limit. 2 into pi by 4 is pi by 2. Lower limit 0. 2 into 0, 0. Cos pi by 2 is 0. Cos 0 is 1. Minus half into 0 minus 1. That is minus 1. So minus into minus becomes plus half. Integral of sin is minus cos. After integrating, you divide by coefficient of x. Coefficient of x is 2. Limits from 0 to pi by 4. Evaluate the function at upper limit minus lower limit. Divide by 2 means 1 by 2 is kept out. So minus half into upper limit is pi by 4. 2 into pi by 4, pi by 2. Cos pi by 2 is 0. Cos 0 is 1. 0 minus 1 minus 1. Minus into minus plus half. Answer is plus half. Next one. Integral from 0 to pi by 2 cos 2x. Integral of cos 2x is sin 2x divided by 2. Evaluate the function at upper limit minus lower limit. Integral of cos 2x is sin 2x divided by coefficient of x, that is 2. Limits from 0 to pi by 2. 0 to pi by 2. Divide by 2 means keep 1 by 2 outside. 1 by 2 outside. Evaluate the function at upper limit minus lower limit. Upper limit is pi by 2. 2 into pi by 2 is pi. Sin pi minus sin of 2 into 0 is 0. Sin pi is 0. Sin 0 is 0. We know that sin of n pi is equal to 0. 0 minus 0 is 0. 0 into half equal to 0. Answer is 0. Next one. Integral of e power x from 4 to 5. We know integral of e power x is e power x. Correct? The student friendly function. Derivative of e power x, e power x. Integral of e power x plus c. For definite integral, we don't add the constant. Anyway, if you add also, it cancels out. E power x plus c. Upper limit minus lower limit. If you do c minus c, will become 0. So e power 5 minus e power 4. Evaluate the function at upper limit minus evaluate the function at lower limit. Upper limit minus lower limit. E power 4 common. What remains is e minus 1. E minus 1. Next one. Integral of tan x. Take the integral as I. I is equal to integral from 0 to pi by 4 tan x. We know integral of tan x is log of mod secant x. Log of mod secant x. Log of mod secant x limits from 0 to pi by 4. Correct? Integral of tan x is log of mod secant x. Limits from 0 to pi by 4. Evaluate the function at upper limit minus evaluate the function at lower limit. Upper limit is pi by 4. So what do you get? Log of mod secant pi by 4 minus log of mod secant 0. Log of mod secant pi by 4 minus log of mod secant 0. Secant pi by 4 is root 2. Secant 0 is 1. Root 2 you can write 2 power half. Correct? Log of 2 power half. And log 1 is 0. Log 2 power half is half log 2. Correct? Answer is half log 2. Or you can write log 2 divided by 2. Log root 2 is log 2 power half, which is half log 2. Hence we get like this. On to the next one. Integral of cosec x. Integral of cosec x is log of mod cosec x minus cot x. Correct? You can use that formula. Otherwise, you can use integral of cosec x is log of mod tan x by 2. Both the formulas are true. Correct? Any formula you can apply. You'll get the same answer. Integral of cosec x. Log of mod cosec x minus cot x. Log of mod cosec x minus cot x. Limits from pi by 6 to pi by 4. Evaluate the function at upper limit minus evaluate the function at lower limit is equal to log of mod cosec pi by 4 minus cot pi by 4. Cosec pi by 4 minus cot pi by 4. Upper limit over. This is upper limit. Evaluate the function at upper limit. Upper limit is pi by 4. Put x equal to pi by 4 minus evaluate the function at lower limit. Lower limit is pi by 6. So cosec pi by 6 minus cot pi by 6. Correct? Take the entire function, put the upper limit. Upper limit is pi by 4. In place of x, put upper limit pi by 4. Lower limit is pi by 6. Put x equal to pi by 6. So what we get? Log of mod cosec. Cosec pi by 4 is root 2. Cot pi by 4 is 1. Correct? Minus log of mod. Here, cosec pi by 6 is 2. And cot pi by 6 is root 3. Correct? Cot pi by 4 is 1. Cosec pi by 4 is root 2. Cosec pi by 6 2. Cot pi by 6 is root 3. Tan pi by 6 1 by root 3. Cot pi by 6 root 3. Now we can use log a minus log b. Log of a by b. Log of mod root 2 minus 1 divided by 2 minus root 3. If you are using the formula for integral of cosec x as log of mod tan x by 2, also get the same answer. This is also equal to another method I am doing, log of mod tan x by 2. Second formula. Okay. Useful for competitive exam. This formula. Limits from pi by 6 to pi by 4. Pi by 6 to pi by 4. Correct? When you put the upper limit here, log of mod tan of pi by 4 by 2 becomes pi by 8. Correct? Put x equal to pi by 4. Pi by 4 by 2 is pi by 8 minus log of mod tan pi by 6 by 2 becomes pi by 12. Correct? Tan pi by 12. Same answer again. See. Is equal to log of mod tan pi by 8 is root 2 minus 1. Mod is not required because it is positive. And tan pi by 12 is 2 minus root 3. Correct? Same answer I am getting. Log a minus log b. Log of a by b. Log of mod. Mod is not required. You can remove that mod because root 2 minus 1 and 2 minus root 3 both are positive. Both are positive. So we get same answer. Any formula you can apply. Either you can use integral of cosec x as log of mod tan x by 2 or log of mod cosec x minus cot x. Any method you can apply and get the answer. Move on to the next one. Integral of dx by root of 1 minus x square. Take the integral as I. I is equal to integral from 0 to 1 dx by root of 1 minus x square. Dx means 1 dx. 1 dx. Integral of 1 by root of 1 minus x square is sin inverse of x. Limits from 0 to 1. We get evaluate the function at upper limit minus evaluate the function at lower limit. Sin inverse of 1 is pi by 2 and sin inverse of 0 is 0. Pi by 2 minus 0. Pi by 2. Correct? Dx means 1 dx. Integral of 1 by root of 1 minus x square is sin inverse of x. Limits from 0 to 1. Evaluate the function at upper limit. Sin inverse of 1 minus sin inverse of 0. Sin inverse of 1 is pi by 2. Sin inverse of 0 is 0. Pi by 2 minus 0. Pi by 2. Next one. Integral from 0 to 1 dx by 1 plus x square. Dx means 1 dx. It is 1 by 1 plus x square with respect to x. We know integral of 1 by 1 plus x square is tan inverse x. Correct? Tan inverse x. Limits from 0 to 1. Evaluate the function at upper limit minus evaluate the function at lower limit. Tan inverse 1 minus tan inverse 0. Tan inverse 1 is pi by 4. Tan inverse 0 is 0. So pi by 4 minus 0, that is pi by 4. Next one. Integral from 2 to 3 dx by x square minus 1. 2 to 3 dx means 1 dx. 1 by x square minus 1 with respect to x. This takes the form 1 by x square minus a square. Integral of 1 by x square minus a square is 1 by 2a log of mod x minus a by x plus a. Correct? We know this formula. Integral of 1 by x square minus a square with respect to x. 1 is same as 1 square. So variable square minus constant square is equal to what? 1 by 2a log of mod x minus a by x plus a. X minus a divided by x plus a plus a constant c. Correct? So in place of a we got 1. Integral of 1 by x square minus a square is 1 by 2a. 1 by 2 into 1 log of mod x minus a divided by x plus a. Limits from 2 to 3. Limits from 2 to 3. Correct? 1 by 2a log of mod x minus a by x plus a. X minus 1 by x plus 1. Evaluate the function at upper limit minus lower limit. 1 by 2 keep outside. Log of mod. Put the upper limit. Upper limit is 3. 3 minus 1 by 3 plus 1. Upper limit you put 3 minus 1 divided by 3 plus 1 minus log of mod. Lower limit is 2. So we get 2 minus 1 divided by 2 plus 1. 1 by 2 into log of how much? 3 minus 1 is 2. 3 plus 1 4 minus log of 2 minus 1 is 1. 2 plus 1 is 3. Correct? Evaluate the function at upper limit. Upper limit is 3. 3 minus 1 by 3 plus 1 minus lower limit is 2. 2 minus 1 by 2 plus 1. Correct? This is equal to 1 by 2 into log of 2 by 4, that is log 1 by 2 minus log 1 by 3, which is equal to 1 by 2 into here log a minus log b, log of a by b, log of 1 by 2 divided by 1 by 3. 1 by 2 by 1 by 3 is 3 by 2. So answer is half log 3 by 2. Half log 3 by 2 we get. Clear? Integral of 1 by x square minus a square formula. 1 by 2a log of mod x minus a by x plus a. Use this formula. Okay. Evaluate the function at upper limit. Upper limit is 3. 3 minus 1, 2. 3 plus 1, 4. 2 by 4. 2 by 4 is half. Minus log of, put the lower limit, 2 minus 1 by 2 plus 1. Here 3, upper limit is 3. So 3 minus 1 by 3 plus 1. 3 minus 1, 2. 3 plus 1, 4. Put the lower limit to 2 minus 1 by 2 plus 1. 2 minus 1 is 1. 2 plus 1, 3. Log 2 by 4 is log 1 by 2. Log 1 by 2 minus log 1 by 3. Log 1 by 2. Log a minus log b. Log of a by b. Log of 1 by 2 by 1 by 3. Log 3 by 2. Half log 3 by 2 is the answer. Move on to the next one. Integral from 0 to pi by 2 cos square x dx. Here we can use the power reducing formula. Of course, we can use the properties of definite integral, but time being we are not studying the properties of definite integral. So I am using the power reducing formula. Cos square x is 1 plus cos 2x by 2. It's called as power reducing formula. 1 plus cos 2x divided by 2. It's called as the power reducing formula. So given integral I is equal to 0 to pi by 2 cos square x. Write the power reducing formula. 1 plus cos 2x by 2. 0 to pi by 2. What we have? 1 plus cos 2x divided by 2. Divided by 2 means keep 1 by 2 outside. 1 by 2 outside. Integral of 1 is x. Integral of cos 2x is sin 2x divided by coefficient of x2. Limits from 0 to pi by 2. Correct? Divide by 2 means keep 1 by 2 outside. Integral of 1 x. Integral of cos 2x sin 2x divided by 2. Evaluate the function at upper limit minus lower limit. Get the answer. So half into upper limit is pi by 2. Correct? Pi by 2 minus 0. Evaluate the function at upper limit minus evaluate the function at lower limit. Pi by 2 minus 0 plus half into evaluate the function at upper limit. 2 into pi by 2 is pi. Sin pi minus sine of 2 into 0, which is 0. Half into, this is pi by 2 plus Sine pi is 0. Sine 0 is 0. Half into 0 there. So this part is 0. Pi by 2 into half is pi by 4. Using power reducing formula. Cos per x 1 plus cos 2x by 2. Divide by 2 means 1 by 2 outside. Integral of 1 x. Integral of cos 2x is sin 2x by 2. Evaluate the function at upper limit minus lower limit. Pi by 2 minus 0. Sin 2x by 2 means half into sin 2x. Half is kept outside. Put the upper limit. 2 into pi by 2 is pi. Sin pi minus sin 0. This is 0. 0 minus 0, 0. Half into 0 is 0. 0 plus pi by 2 is pi by 2. Pi by 2 and half is pi by 4. Next one. Integral from 1 to root 3 dx by 1 plus x square. Given as a multiple choice question as given in the NCERT book. So I is equal to integral from 1 to root 3 dx means 1 dx. So 1 by 1 plus x square with respect to x. Integral of 1 by 1 plus x square is tan inverse x. Tan inverse x. Limits from 1 to root 3. Evaluate the function at upper limit minus evaluate the function at lower limit. Tan inverse root 3 minus tan inverse 1. Correct? Evaluate the function at upper limit minus evaluate the function at lower limit. Tan inverse of root 3 is pi by 3. As you know, tan pi by 3 is root 3. Tan pi by 4 is 1. So tan inverse of 1 is pi by 4. Pi by 3 minus pi by 4. Take LCM. 3 and 4 LCM is 12. 3 into 4. So we get 4 pi minus 4 into 3. Get 3 pi. 4 pi minus 3 pi which is pi by 12. Pi by 12 we get. Answer is option D. Move on to the next one. Integral from 0 to 2 by 3 dx by 4 plus 9x square. Take the integral as I. I is equal to integral from 0 to 2 by 3 dx means 1 dx. 1 by 4 plus 9x square. 4 plus 9x square dx. Correct? So this is equal to integral from 0 to 2 by 3. I can write this as 1 by 2 square plus 3x the whole square. Correct? This takes the form integral of 1 by a square plus x square. A square plus x square. 1 by a square plus x square is 1 by a tan inverse x by a. Correct? So 1 by 2 tan inverse of 3x by 2 divided by coefficient of x. Coefficient of x is 3. So divide by coefficient of x. So this is equal to 1 by a. 1 by 2 tan inverse of 3x divided by 2 divided by coefficient of x is 3. After integrating, I should divide by coefficient of x because the formula is we have 1 by a square plus x square. Integral of 1 by a square plus x square is 1 by a tan inverse x by a. 1 by a tan inverse x by a plus c. Correct? So instead of x we have 3x. So after integrating, I should divide by coefficient of x. 1 by 2 tan inverse of 3x by 2. Tan inverse of x by a. Instead of x we have 3x. Instead of a we got 2 divided by coefficient of x that is 3. Limits from 0 to 2 by 3. Limits from 0 to 2 by 3. 1 by 2 into 3 that is 1 by 6. Here the denominator gets multiplied. 2 into 3 6. Evaluate the function at upper limit. So what do you get? Tan inverse of here putting x equal to 2 by 3. 3 by 2 into x. X is 2 by 3 minus tan inverse of 3 by 2 into 0. Correct? Evaluate the function at upper limit. In place of x, put the upper limit. Upper limit is 2 by 3. Minus, evaluate the function at lower limit. This is 0. Tan inverse of 0 is 0. 3, 3 cancels. 2, 2 cancels. Tan inverse of 1, which is pi by 4. So 1 by 6 into tan inverse of 1 minus tan inverse of 0. Tan inverse of 0 is 0. Tan inverse of 1 is pi by 4. So I get 1 by 6 into pi by 4, which is, this part is 0. I won't write that. So answer is pi by 24. Answer is pi by 24. Option C is the answer. Move on to the next one. Integral from 1 to 2, 5x square by x square plus 4x plus 3. Here I can integrate by using partial fractions, or else you can do first you have to integrate this by partial fraction, one method. Otherwise you can write the numerator in terms of denominator and use linear by quadratic. There are two ways of doing this problem. If I am going by partial fraction, no, this is improper rational function because the degree of numerator is equal to degree of denominator. Two ways of doing this problem. One is directly use method of partial fraction. First of all, it is an improper rational function. Express it as sum of a rational function and some other polynomial. Okay, use improper rational function is equal to quotient plus remainder by denominator, that form. Or else you can use, first you can add and subtract 4x plus 3, 5 you can keep outside, add and subtract 4x plus 3, so that numerator in terms of denominator we are expressing 1 minus, will get linear by quadratic. Linear by quadratic means you can use the method. So take numerator is equal to a plus b into derivative of denominator, that method. I'll go by method of partial fractions for this. Okay, so consider this 5x square by x square plus 4x plus 3. First I'll consider the indefinite integral and integrate completely. At last step I apply the limits, lower limit and upper limit. So consider integral of 5x square by, consider integral of 5x square divided by x square plus 4x plus 3. X square plus 4x plus 3. Consider this integral. Okay. So what we'll do is evaluate, you can divide this first. It's an improper rational function because degree of numerator is 2. Degree means highest power of x. Here the highest power of x is 2 in the numerator. Denominator also highest power of x is 2. Degree of numerator is equal to degree of denominator. So improper rational function. Improper rational function cannot be resolved into partial fractions. Correct? First you have to express it as quotient plus remainder by denominator. So we'll divide long division for this. Apply long division for this. 5x square is there. Correct? Dividing by x square plus 4x plus 3. I am dividing by x square plus 4x plus 3. X square you have to multiply by 5 to get 5x square. Correct? X square into 5 gives 5x square. 4x into 5, that becomes 20x. 3 into 5 is 15. Correct? Change the sign. Minus, minus, minus will cancel. So what you get is minus 20x minus 15. 4x into 5 is 20x. 3 into 5 is 15. Subtract. 5x square cancels. We get minus 20x minus 15. So improper rational function is equal to quotient. Further I can't divide because degree of the remainder is less than the degree of the divisor. So improper rational function is equal to quotient plus remainder by denominator. Okay, that one I'm going to use. 5x square divided by x square plus 4x plus 3. Correct? This you can write it as quotient plus remainder divided by denominator. What is quotient? Quotient is 5. Quotient is 5. What is remainder? Remainder is this, minus 20x minus 15. Correct? That's a remainder. Minus 20x minus 15, correct? Remainder we got minus 20x minus 15. Divided by denominator. Denominator is x square plus 4x plus 3, correct? Quotient plus remainder by denominator. Now consider this. Integral of, I need to integrate this. If you want to integrate this, I need to integrate this as well as this. Integral of 5 is 5x. To integrate this, I can use method of partial fractions. Okay, consider minus 20x minus 15. Consider minus 20x minus 15 divided by, this will factorize it as x plus 1 into x plus 3. Quadratic can be factorized. X plus 1 into x plus 3. This is a by x plus 1 plus b by x plus 3. Resolving into partial fractions. So take common denominator. What we get? X plus 1 into x plus 3. Common denominator. A into x plus 3 plus b into x plus 1. A into x plus 3 plus b into x plus 1. Here it is minus 20x minus 15 divided by x plus 1 into x plus 3. This will cancel. X plus 1 into x plus 3 cancels. So what we get is minus 20x minus 15 is equal to a into x plus 3 plus b into x plus 1. Call this as star. Find the constants a and b now. To find the constants a and b, first I'll put x plus 1 equal to 0 in star. Then put x plus 3 equal to 0 in star. You get the values of a and b. Once you get the values of a and b, substitute back and then integrate. Put x plus 1 equal to 0. So put x plus 1 equal to 0 in star. That is put x equal to minus 1. Put x equal to minus 1 in equation star. What we get? Minus 20 into minus 1 becomes plus 20. Minus 15. Correct? Putting x equal to minus 1. Minus 20 into minus 1 becomes plus 20. 20 minus 15 is equal to a into, I'll get minus 1 plus 3. Plus this part will become 0. Correct? Minus 1 plus 1 0. This part is gone. 20 minus 15 is 5. This is 2a. Correct? So a is equal to 5 by 2. I'm getting. The value of a is 5 by 2. Next put x plus 3 equal to 0 in star. That is put x equal to minus 3 in star. Put x equal to minus 3 in equation star. What we get? Minus 20 into minus 3. That becomes plus 60. Minus 15 is equal to, this is minus 3 plus 3 0. This part will become 0. I won't write that. Plus b into what I get? Minus 3 plus 1. That is minus 2. Correct? So I'll get b is equal to minus 45 by 2. B is minus 45 divided by 2. A and B both I got. A we got 5 by 2. A is 5 by 2. And B is minus 45 by 2. We got the values of A and B. Substitute there. Then we can integrate. Then we can apply the limits from 1 to 2. This part we can drop. It's not required anymore. So, therefore, what we have is 5x square by x square plus 4x plus 3 is 5 plus given integral is that top, correct? So 5x square divided by x square plus 4x plus 3. This is equal to 5 plus, correct? This part is same as sum of these two. A we got 5 by 2. A is 5 by 2 divided by x plus 1. B we got minus 45 by 2 minus 45 by 2 divided by x plus 3. Integrate this with respect to x. Integral of 5x square by x square plus 4x plus 3 with respect to x. Integral of 5 with respect to x. 5 by 2 keep outside. Integral of 1 by x plus 1. Minus 45 by 2 keep outside. Integral of 1 by x plus 3. Integral of 5 is 5x. 5 by 2 keep outside. Integral of 1 by x plus 1 is log of mod x plus 1. Correct? Minus 45 by 2. Integral of 1 by x plus 3 is log of mod x plus 3. Of course, you're dividing by coefficient of x1. If you're applying this as a definite integral, this becomes limits from 1 to 2, no? 1 to 2. Integral from 1 to 2. Correct? Everywhere. Integral from 1 to 2. So for this limits from 1 to 2, I'll write 1 to 2. For this limits from 1 to 2. Limits from 1 to 2. So what do you get? This is equal to 5 into upper limit minus lower limit. 2 minus 1 is 1. 5 by 2 into upper limit is 2. 2 plus 1 3. Log 3 minus log of 1 plus 1 2 minus 45 by 2 into upper limit is 2. 2 plus 3 becomes 5. Log 5 minus log of 1 plus 3, that is log 4. Correct? Like this we get. So simplify this one more step. I can write log 4 as log 2 square, which is 2 log 2. Otherwise keep as it is. So I'll write the answer here. I'll call this integral as I here. I is equal to, therefore the integral I becomes equal to what? The integral I is equal to 5 plus 5 by 2 into log 3 minus log 2 is log of 3 by 2. Log of 3 by 2. Correct? Minus 45 by 2 into log a minus log b. Again using property log of a by b. Log of 5 by 4. This is the answer. Value of the given integral is so much. If you want, you can simplify this further or else keep as it is. Move on to the next one. Integral from 0 to pi by 4, 2 secant square x plus x cube plus 2. So take the integral as I is equal to integral from 0 to pi by 4, 2 into secant square x plus x cube plus 2. Correct? Integrate this and apply limits. 2 into integral of secant square x is tan x. Integral of x cube is x power 4 divided by 4. And integral of 2 is 2x. Integral of constant is constant into x. Integral of secant square is tan. Integral of x cube is x power 4 by 4. Correct? Limits from 0 to pi by 4. Evaluate the function at upper limit minus lower limit. So 2 into, this is tan pi by 4 minus tan 0. Correct? Evaluate the function at upper limit minus lower limit. Plus x power 4 by 4 is 1 by 4 into x power 4. For x power 4, apply the limits. Upper limit minus lower limit. Pi by 4 to the power 4 minus 0 power 4 plus 2 into pi by 4 minus 0. Tan pi by 4 is 1. 2 into 1 minus 0. Correct? Here 1 by 4 into pi power 4 divided by 4 power 4 is 256. 0 I won't write. 2 into pi by 4 is pi by 2. So this is equal to 2 plus pi power 4 divided by 256 into 4 is 1024 plus pi by 2. Correct? Move on to the next one. Here we can make use of the formula. We know cos x is equal to cos square x by 2 minus sin square x by 2. Half angle formula. Correct, for cos x. Cos square x by 2 minus sin square x by 2 is cos x. But what is given in the question is sin square x by 2 minus cos square x by 2. Multiply by minus 1. If you multiply by minus 1, I get minus cos x is equal to this will be sin square x by 2 minus cos square x by 2. Sin square x by 2 minus cos square x by 2. Multiply by minus 1. So the given integral becomes 0 to pi sin square x by 2 minus cos square x by 2 is minus cos x. Correct? Because cos square x by 2 minus sin square x by 2 is cos x. Multiply by minus 1. Minus cos x will be equal to sin square x by 2 minus cos square x by 2. Correct? Integral of minus cos x is minus sin x. Limits from 0 to pi. Evaluate the function at upper limit minus lower limit. Minus of what we get is sin pi minus sin 0. Sin pi is 0. Sin 0 0. 0 minus 0 is equal to 0. Minus of 0 minus 0 which is equal to 0. Sin of n pi is equal to 0 and answer is 0. Move on to the next one. Integral from 0 to 1 x into e power x plus sin of pi x by 4. Correct? Integral of x into e power x will do separately. That is by parts we should do. Consider integral of x into e power x. X is algebraic, e power x is exponential. Correct? So integral of first into second by Eilert rule. E power x is exponential. Exponential is the second function. Algebraic comes before exponential according to Eilert. If you integrate this by parts, first function keep as it is. Integral of e power x is e power x minus integral of integrate the second function, differentiate the first function. Integral of integrate e power x, derivative of x is 1. Correct? So I wrote the formula directly. First function keep as it is. Integrate e power x, that is e power x, minus integral of integrate the second function, differentiate the first function. So this is equal to x into e power x minus integral of e power x is e power x. Correct? So 0 to 1 x into e power x dx. Correct? Plus integral from 0 to 1 sin of pi x by 4. Like this we have. Integral of x into e power x, we got it as x into e power x minus x plus c. Of course, no need to add a constant c for definite integral. It will cancel out even though if add x into e power x minus e power x. Limits from 0 to 1. Integral of sin is minus cos pi x by 4 minus cos pi x by 4 divided by coefficient of x which is pi by 4. Correct? Limits from 0 to 1. Correct? Integral of x into e power x is x e power x minus e power x. Correct? That is what I got. And integral of sin is minus cos of pi x by 4 divided by coefficient of x is pi by 4. For this, apply limits. And I put the upper limit here. 1 into e power 1 minus e power 1. Upper limit over. Lower limit. Put x equal to 0. 0 into e power 0 minus e power 0. Correct? Upper limit x equal to 1. 1 e power 1 minus e power 1 minus 0 into e power 0 minus e power 0. 1 by pi by 4 is 4 by 5. 4 by pi into, evaluate the function at upper limit. What do you get? Cos of x equal to 1, you put pi by 4 minus cos 0. Correct? Evaluate the function at upper limit minus lower limit. E minus e is 0. Correct? 0 minus, this is 0. Correct? This part is 0. This part is 0. Minus of minus becomes plus and e power 0 is 1. Correct? Minus 4 by pi into what we have? Cos pi by 4 is 1 by root 2. Cos 0 is 1. E minus e is 0. 0 into e power 0 is 0. Minus into minus plus. E power 0 is 1. So what I am getting is 1 minus 4 by pi root 2. Correct? Minus into minus becomes plus 4 by pi. Correct? 1 by pi by 4 is 4 by pi. Cos pi by 4 is 1 by root 2. Cos 0 is 1. Hence we get like this. 1 minus 4 by pi root 2 plus 4 by pi. Move on to the next one. Question number 18 was over. 19th one. Integral from 1 to e dx by x. Dx by x means integral of 1 by x with respect to x. Integral of 1 by x with respect to x. Limits from 1 to e. Integral of 1 by x is log of mod x. Log of mod x. Limits from 1 to e is equal to. Evaluate the function at upper limit. Log of mod e minus log of mod 1. Correct? This is log e is 1 and log 1 is 0. 1 minus 0, 1. Mod e is same as e. Log e is 1. Log 1 is 0. 1 minus 0 is 1. Next one. Integral of x square. Integral of x square is x cube by 3. Correct? Very simple question. Integral of x square is x cube divided by 3. Limits from 2 to 3. Limits from 2 to 3. Evaluate the function at upper limit minus lower limit. 3 cube minus 2 cube. 3 cube is 27. 2 cube is 8. 27 minus 8, that is 19 by 3. 3 cube minus 2 cube. 27 minus 8, 19 by 3. Next one, we can integrate this by partial fractions and then apply the limits. Consider x by x plus 1, x plus 2. First consider x by x plus 1 into x plus 2. Dissolve this into partial fraction. This is a proper rational function. Correct? Denominator contains 2 brackets. So split this into 2 fractions. Correct? 2 terms I'll get. A by x plus 1 plus b by x plus 2. Sum of 2 rational functions. Because denominator contains 2 brackets, I can express it as sum of 2 rational functions. A by x plus 1 plus b by x plus 2. Our aim is to find a and b. To find a and b, take common denominator. Put x plus 1 equal to 0. Put x plus 2 equal to 0. Determine the constants a and b. Integrate, then apply the limits. Taking common denominator here. X plus 1 into x plus 2. What we get? A into x plus 2 plus b into x plus 1. A into x plus 2 plus b into x plus 1. Taking common denominator. This is x by x plus 1 into x plus 2. X plus 1 into x plus 2 cancels denominator. So we get x is equal to a into x plus 2 plus b into x plus 1. Call this equation star. Our aim is to find the constants a and b. So to find the value of a, put x plus 1 equal to 0. X plus 1 0 means x equal to minus 1. Put x equal to minus 1 in equation star. Put x equal to minus 1 in equation star. What we get? Minus 1 is equal to a into minus 1 plus 2 1 plus b into minus 1 plus 1 0. B into 0 0. So what we get? A equal to minus 1. A is equal to minus 1. Next put x equal to minus 2 in star. Put x equal to minus 2 in equation star. Put x equal to minus 2 here. Minus 2 is equal to a into minus 2 plus 2 is 0 plus b into what we get? Minus 2 plus 1, that is minus 1. So a into 0, 0 minus b equal to minus 2. So I'll get b is equal to 2. A is minus 1, b is 2. Correct? Putting x equal to minus 1. Minus 1 is equal to a into minus 1 plus 2 is 1. Minus 1 plus 1, 0. A into 1, a is minus 1. Put x equal to minus 2 in star. Minus 2 is equal to a into 0. Minus 2 plus 2, 0. B into minus 2 plus 1, minus 1. So minus b equal to minus 2. So b is equal to 2. Put a and b values here. Then integrate. Therefore we get integral of x by x plus 1 into x plus 2. With respect to x is equal to integral of a we got minus 1. So minus 1 divided by x plus 1 with respect to x. Plus integral of b we got 2. 2 by x plus 2. 2 by x plus 2. Correct? Is equal to minus 1 keep outside. Integral of 1 by x plus 1 is log of mod x plus 1. Plus 2 into integral of 1 by x plus 2 is log of mod x plus 2. For this we can apply the limits and get the answer. Log of mod x plus 2. Okay. So limits from 1 to 2. No, integration is from 1 to 2 everywhere. 1 to 2. Integral from 1 to 2. For this evaluate the function at upper limit minus lower limit. 1 to 2. 1 to 2. So this is equal to minus 1 into evaluate the function at upper limit. Log of what we get? 2 plus 1 3. Correct? Minus log of 1 plus 1 2. Upper limit minus lower limit. Evaluate the function at upper limit. X equal to 2 equal 2 plus 1 3 minus log of 1 plus 1 2 plus 2 into what we get? Evaluate the function at upper limit. Log of 2 plus 2 becomes 4 minus log of 1 plus 2 that is 3. Correct? Evaluate the function at upper limit minus lower limit. Log of 2 plus 2 log 4 minus log of 2 plus 1 that is 3. Log 4 minus log 1 plus 2 is 3. Correct? Evaluate the function at upper limit. 2 plus 2 is 4 minus log of 1 plus 2 is 3. So this is minus of, correct, is equal to minus 1 into log 3 minus log 2, log of 3 by 2. And here 2 times log 4 minus log 3, log of 4 by 3. And this we can write it as 2 log 4 by 3 is log 16 by 9. Correct? 2 goes up. So minus log 3 by 2 keep as it is. Minus log 3 by 2 plus 2 log 4 by 3 is log of 4 square is 16 and 3 square is 9. Further I can use property log a minus log b, log of a by b. So this will be log 16 by 9 divided by 2 by 3. 16 by 9 divided by 2 by 3. Correct? Sorry, 3 by 2. 3 by 2. Log of 16 by 9 divided by 3 by 2. That is log of 2 goes up, right? 2 goes to numerator. 2 into 16 is 32. And 9 comes down. 3 into 9 is 27. So log of 32 by 27. Correct? 2 goes to numerator. 2 into 16 is 32. 9 comes to denominator. 9 into 3 is 27. Log of 32 by 27. This is the answer. Move on to the next one. Next we got some integrals where we make a substitution. Whenever we want to make a substitution with definite integral, integral which involves the definite integral with substitution, if you are doing, put t is equal to the substitute, whatever you are going to substitute, name it as t, differentiate with respect to x, then change the limits. Whenever you make a substitution, differentiate and change the limits, then integrate, then apply the limits. That is what I given here, the steps to be followed. So make a proper substitution, differentiate. Suppose a t is equal to some function you're going to substitute, differentiate the given function with respect to x, with respect to the original variable, differentiate and change the limits, because the original limits were given only for x. Now you should write the limits, lower limit and upper limit in terms of a new variable. Okay, new variable, in terms of the new variable you should write the lower limit and upper limit, then integrate, then apply the limits. That is what the steps are given here. Okay, to make you understand how to integrate a function involving the definite integral if you are making a substitution. There are some questions based on this. We shall take one by one. This is question number 1. We have integral from 2 to 3 x dx by x square plus 1. So take the integral as I here. I is equal to integral from 2 to 3 x divided by x square plus 1 dx. To integrate this, we make a substitution x square plus 1 equal to t, because derivative of x square plus 1 is 2x. So that x into dx will be dt by 2. Correct? Numerator can be derived from denominator. Of course, this is very standard one. Integral of x by x square plus 1 is half log x square plus 1. We know it's a very standard one. Okay? But still, I'll do all the steps. Put t equal to x square plus 1. Put t equal to x square plus 1. Differentiate this. dt by dx. Derivative of x square 2x. Derivative of 1 0. From this I can write it as dt by 2 is equal to x into dx. dt by 2 is equal to x into dx. So x into dx will be dt by 2. Now we need to change the limits, because these limits are valid only for x. X varies from 2 to 3. T varies from what to what. To find out. So when x is equal to 2, find out t equal to how much. When x is equal to 2, t is equal to how much? 2 square plus 1, 2 square 4, 4 plus 1 5. When x is equal to upper limit is 3. When x is equal to 3, t is equal to how much? 3 square plus 1, 9 plus 1, 10. So limits will change. X is 2 to 3, t is from 5 to 10. Correct? Integral from 5 to 10. 5 to 10. What is x into dx? X into dx is a dt by 2. X into dx is dt divided by 2. Divided by x square plus 1 is t. X square plus 1 is t. dt by 2 means keep 1 by 2 outside. 1 by 2. Integral from 5 to 10 dt by t. Integral of dt by t is log of mod t. Half into log of mod t. Limits from 5 to 10. Correct? dt by 2 means keep 1 by 2 outside. Integral of dt by t is log of mod t. Evaluate the function at upper limit minus lower limit is equal to half into. Evaluate the function at upper limit log 10 minus log 5. Correct? Is equal to half into log a minus log b. Log of a by b. 10 by 5. 10 by 5 is 2. So answer is half log 2. Is that clear? X into dx is dt by 2. So x into dx is dt by 2. X square plus 1 is t. Change the limits. When x is 2, lower limit is 2. Find out t equal to how much? 2 square plus 1, 4 plus 1, 5. When x is equal to 3, t is equal to 3 square plus 1, 9 plus 1, 10. So limits from 5 to 10. dt by 2 means keep 1 by 2 outside. Integral of dt by t is log of mod t. Limits from 5 to 10. Log 10 minus log 5. Log of 10 by 5. 10 by 5 is 2. So answer is half log 2. This is how we have to do whenever the given integral is a definite integral, and if you're doing the method of substitution, that in that case make a proper substitution, differentiate with respect to x, the given variable is x, so differentiate with respect to the original variable, change the limits and integrate and apply limits, get the answer. Okay. Next one is integral from 0 to 1, 2x plus 3 by 5x square plus 1. So this integral I can write it as I is equal to integral from 0 to 1, 2x plus 3 divided by 5x square plus 1. Separate the terms. Numerator is sum of two terms. Now separate it. 0 to 1, 2x divided by 5x square plus 1 plus integral from 0 to 1, 3 by 5x square plus 1. Separating the terms, because numerator is sum of two terms. Numerator is sum of two terms. Separate 2x by 5x square plus 1, 3 by 5x square plus 1. Correct? To integrate this, use method of substitution. This is directly we can integrate. Of course, you can take 5 outside and integrate using the formula 1 by x square plus a square, 1 by a tan inverse x square. That formula I can use. For this, I can make a substitution for this. For the first integral, put t equal to denominator. Derivative of 5x square plus 1 is 10x. So x into dx will be dt by 10. And whenever you make a substitution, you differentiate and you have to change the limits. Okay, that thing should be there. So put t equal to 5x square plus 1 for the first integral. Okay, put t is equal to 5x square plus 1. Put t is equal to denominator 5x square plus 1. Differentiate this. Dt by dx. Dt by dx. Derivative of 5x square is 10x. Derivative of 1 is 0. So from this, dt divided by 10 is equal to x into dx. Correct? dt by 10 is equal to x into dx. Change the limits. When x is equal to 0, t equal to how much? When x is equal to 0, t is equal to how much? 5 into 0 square, 0. 0 plus 1, 1. When x is equal to upper limit is 1. When x is equal to 1, t is equal to how much? 5 into 1 square, 5. 5 plus 1, 6. Correct? Limits will change from 1 to 6. When x is 0, t is equal to 1. When x is 1, t is equal to 6. Correct? Limits will change from 1 to 6. 1 to 6. 2 we can keep outside the integral. X into dx is dt by 10 from this. X into dx is dt by 10. Dt by 10 divided by 5x square plus 1 is t. Here 3 you can keep outside. And I take 5 outside from this. 3 by 5 integral from 0 to 1. 1 by x square plus 1 by 5. Taking 5 outside from the denominator. 5 outside from this. Correct? dt by 10 means 1 by 10 keep outside. 2 into 1 by 10 becomes 1 by 5. 1 by 5. Integral of 1 to 6. dt by 10. Integral of dt by t. Log of mod t. This is 3 by 5. Integral from 0 to 1. 1 by x square plus this is 1 by 5 is 1 by root 5 square. Correct? This form I am getting. Integral of 1 by x square plus a square. 1 by tan inverse x by dt by 10 means 1 by 10 keep outside. 2 by 10 is 1 by 5. Integral from 1 to 6 dt by t. dt by t means integral of 1 by t with respect to t, which is log of mod t. 1 by 5 log of mod t. Log of mod t. Limits from 1 to 6 plus 3 by 5 into integral of 1 by x square plus a square. 1 by a tan inverse x by 1 by a is 1 by root 5 here. Correct? Tan inverse of x by a. Tan inverse of x divided by 1 by root 5. Correct? Limits from 0 to 1. Evaluate the function at upper limit minus lower limit. Therefore, the given integral I becomes equal to, I'll write here, what we have 1 by 5 into 1 by 5 into. Evaluate the function at upper limit. Log 6 minus log 1. Upper limit minus lower limit. So what we get is log 6 minus log 1. Evaluate the function at upper limit minus evaluate the function at lower limit. Here 5 is root 5 into root 5. So 1 root 5 will cancel. 3 by root 5 becomes 3 by root 5. Correct? Into tan inverse of x root 5 becomes. Correct? 1 by root 5 is root 5. Tan inverse of x root 5 limits from 0 to 1. When you put the upper limit x equal to 1, 1 by root 5. So tan inverse of root 5 I am getting. Tan inverse of root 5 minus when you put x equal to 0, correct? Root 5 into 0. That becomes tan inverse of 0. So this is equal to log 1 is 0 and tan inverse of 0 is also 0. So what we get is 1 by 5 into log 6 plus 3 by root 5 into tan inverse of root 5. 3 by root 5 into tan inverse of root 5. Tan inverse of 0 is 0. Correct? 1 root 5 got cancelled. 3 by root 5 tan inverse of root 5 is root 5 into 1 root 5 tan inverse of root 5. Lower limit is 0. Tan inverse of root 5 into 0. Root 5 into 0 0. Tan inverse of 0 is 0. So this is 0, this is 0. So 1 by 5 log 6 plus 3 by root 5 into tan inverse of root 5 is the answer. Correct? I take 5 common from this. Even though it's not common, taken out. So balance it by dividing by 5. So 3 by 5 kept outside. 1 by x square plus a square formula. Integral of 1 by x square plus a square is 1 by a tan inverse of x by 1 by root 5. 5 is root 5 into root 5. 1 root 5 cancels. So you get 3 by root 5. Tan inverse of upper limit minus lower limit. Get the answer. Tan inverse of upper limit minus tan inverse of lower limit. This is the final answer. Okay. Separating the terms. One integral should be done by method of substitution. The first one is evaluated by method of substitution as shown here, and the second one is direct by taking 5 out. Even though it's not common, take it out and balance it by dividing by 5. Hope you understand. Move on to the next one. This also we can use method of substitution here. Put t equal to x square. Put t is equal to x square. Differentiate this. dt by dx. Derivative of x square is 2x. From this, I can write dt by 2 is equal to x into dx. Correct? dt by 2 is equal to x into dx. X into dx will be dt by 2. Whenever you make a substitution, differentiate and you have to change the limits. Write the limits in terms of the new variable t. When x is 0, t equal to how much? When x is equal to 0, t is equal to how much? When x is equal to 0, t is equal to 0 square, 0. When x is equal to upper limit is 1, correct? When x is equal to 1, t is equal to 1 square, which is 1. So given integral I is equal to 0 to 1 x into e power x square. This becomes, I am writing in terms of the new variable now. So limits will be 0 to 1 only. X is 0 to 1, even t is 0 to 1 because 0 square is 0, 1 square is 1. Limits will remain same, 0 to 1. What is x into dx? X into dx is dt by 2. dt by 2 is 1 by 2 keep outside. dt, correct? E power, what is x square? X square is t. X square is t. X into dx is dt by 2, it's half dt. E power t. Integral of e power t is e power t. E power t, limits from 0 to 1. Correct? This is half into. Evaluate the function at upper limit minus lower limit. So answer is half into e power 1 is e power 0 is 1. Correct? X into dx is dt by 2 from this. X into dx is dt by 2 means half dt. E power x square is t. Integral of e power t is e power t. Limits from 0 to 1. Evaluate the function at upper limit minus lower limit. E power 1 minus e power 0. E power 0 is 1. Half e minus 1 is the answer. Move on to the next one. Integral from 0 to 2. This is not same, no? Different. So here also this question is similar to question number 2 we did, correct? This question is almost same as this. 2x plus 3 by 5x square plus 1. Separate the terms and integrate. Here also we are doing the same, correct? Take the integral as I. I is equal to integral from 0 to 2. 6x plus 3 divided by x square plus 4. Separate the terms. Divide individually. What we get? This is equal to integral from 0 to 2. 6x divided by x square plus 4 with respect to x plus integral from 0 to 2 3 by x square plus 4 dx. Separating the terms. Okay. The first integral can be done by method of substitution. Second one is direct. 3 you can keep outside. 1 by x square plus a square formula. 1 by a tan inverse x by. First integral can be done by method of substitution. Put t equal to x square plus 4. Put t equal to x square plus 4. Differentiate x square plus 4. Okay. dt by dx. dt by dx. Derivative of x square is 2x. Derivative of 4 is 0. So from this what we get? dt by 2 is equal to x into dx. Whenever you make a substitution, you have to differentiate and you have to change the limits. So when x is equal to 0, find t equal to how much? When x is equal to 2, find out t equal to how much? When x is equal to 0, lower limit is 0, right? When x is equal to 0, when x is equal to 0, t is equal to how much? 0 square, 0 plus 4, 4. When x is equal to upper limit is 2. When x is equal to 2, t is equal to how much? T is equal to 2 square, 4, 4 plus 4, 8. Correct? When x is equal to 0, t equal to how much? 0 square plus 4, 4. When x is equal to 2, t is equal to 2 square, 4 plus 4, 8. So limits will change now. 6 you can keep outside the integral. X into dx is dt by 2. Correct? So 6 you keep outside. 6 which will keep outside. Integral from 0 to 2. 0 to 2 becomes 4 to 8. When x is 0, t is 4. When x is 2, 2 square 4, 4 plus 4, 8. Limits will change from 4 to 8. 4 to 8, correct? 4 to 8. What is x into dx? X into dx is dt by 2. So dt by 2. dt by 2 divided by x square plus 4 is t. 3 you keep outside. Integral from 0 to 2, 1 by x square plus 2 square. Correct? 6 by 2, that is 3. dt by 2 is 1 by 2, keep outside. 6 by 2 is 3. Integral from 4 to 8, dt by t. Integral of dt by t is log of mod t. Correct? And this is integral from 0 to 2, 1 by x square plus a square formula. 1 by tan inverse of x by a we can use and get the answer. Integral of dt by t is log of mod t. That means integral of 1 by t with respect to t. Log of mod t. Correct? So 3 times log of mod t, limits from 4 to 8. Limits from 4 to 8. Plus 3 into integral of 1 by x square plus a square is 1 by a tan inverse x by a. So instead of a we have 2. 1 by 2 tan inverse of x by 2. Limits from 0 to 2. Correct? Evaluate the function at upper limit minus lower limit. Get the answer. I is equal to what we have 3 into log 8 minus log 4. Evaluate the function at upper limit minus lower limit. Log 8 minus log 4 plus here 3 by 2 into what we have tan inverse of upper limit 2 by 2 tan inverse of 2 by 2 minus tan inverse of 0 by 2. Upper limit minus lower limit. Tan inverse of 2 by 2 minus tan inverse of 0 by 2. Correct? This is 3 times log a minus log b. Log of a by b. Log of 8 by 4 plus 3 by 2 into. This is tan inverse of 1. Tan inverse of 1 is pi by 4 and tan inverse of 0 is 0. Correct? So what do you get? 8 by 4 is 2. So this becomes 3 log 2. 3 log 2 plus here 3 pi by 8 I am getting. Correct? 3 pi by 8. If you want you can write log 3 log plus log 2 cube. Log 8 we can write or keep as it is. You can take 3 common otherwise. If you take 3 common I get log 2 plus pi by 8. Log 2 plus pi by 8. Like this also we can keep. Hope it's clear. The value of integral is so much. Hope it's clear. Separating the terms. 6x by x square plus 4 plus 3 by x square plus 4. 3 is kept outside. 1 by x square plus a square. 1 by a tan inverse x by a. Limits from 0 to 2. dt by 2. Correct? Putting t equal to x square plus 4. Derivative of x square is 2x. Derivative of 4 0. So dt by 2 is equal to x into dx. When x is equal to 0, t equal to 4. When x is equal to 2, t is equal to 8. Those limits from 4 to 8. 6 kept outside. X into dx is dt by 2 from this. Okay? dt by 2. 1 by 2 is kept outside. 6 by 2 will be 3. Correct? Integral from 4 to 8 dt by t. Integral of dt by t is log of mod t. Limits from 4 to 8. Log 8 minus log 4. Log of 8 by 4. That is log 2. 3 log 2 plus 3 pi by 8. That's the answer. Move on to the next one. Question number 5. Take the integral as I here. I is equal to integral from 4 to 9 root x divided by 30 minus x power 3 by 2 the whole square. Put t is equal to terms inside the bracket. You can use the method of substitution here. Put t is equal to 30 minus x power 3 by 2. Put t is equal to 30 minus x power 3 by 2. Differentiate this. dt by dx. Derivative of 30 is 0. Derivative of constant is 0. Derivative of x power 3 by 2 is 3 by 2 x power 3 by 2 minus 1. Correct? 3 by 2 into x power 3 by 2 minus 1. That is minus 3 by 2 into x power 3 by 2 minus 1 is half. This is dt by dx. dt by dx. This is x power half is root x. I find out what is root x into dx. Minus 3 by 2, take that, it becomes minus 2 by 3, becomes reciprocal. Minus 2 by 3 into dt is equal to root x into dx. Correct? X power half is root x. Minus 3 by 2, take that, it becomes minus 2 by 3 into dt, cross multiply. So root x into dx is minus 2 by 3 dt. Also, I need to change the limits. Whenever you make a substitution, you differentiate and change the limits. When x is equal to 4, t equal to how much we find out? When x is equal to 4, t is equal to 30 minus 4 power 3 by 2. 4 power 3 by 2 is 4 root 4. You must know that a power 3 by 2 is a root a. Correct? Because a power 1 into a power half. 1 plus half. 1 and half. 3 by 2. So this will be 30 minus 4 power 3 by 2 is 4 root 4. So this is 30 minus root 4 is 2. 2 into 4, 8. So this becomes 22. When x is equal to 9, you find out t equal to how much? When x is equal to 9, when x is equal to 9, t is equal to how much? 30 minus 9 power 3 by 2. 30 power 3 by 2 is 9 root 9. Because a power 3 by 2 is a root a. Learn this. Okay. So 9 power 3 by 2 is 9 root 9. Root 9 is 3. 3 into 9 is 27. 30 minus 27 is equal to 3. I'm getting 3. 9 root 9 is 27. 30 minus 27 is 3. So limits will change. When x is 4, t is 22. When x is 9, t is 3. Limits from 22 to 3. So lower limit is 22 and upper limit is 3. Root x into dx is minus 2 by 3 dt. So minus 2 by 3 you can keep outside. Minus 2 by 3 dt divided by terms inside the bracket is taken as t. So denominator is t square. Dt means 1 dt. So integral of 1 by t square is minus 1 by t. Integral of 1 by t square is minus 1 by t. Limits from 22 to 3. Minus into minus plus 2 by 3 into 1 by t. For this limits from 22 to 3. 2 by 3 into evaluate the function at upper limit. What do you get? 1 by 3 minus 1 by 22. Correct? That's equal to 2 by 3 into, take LCM, 3 and 22, LCM is 66. 3 into 22 gives 66, 22 into 1, 22. 22 3s are, so 3 into 1. So this will be 2 by 3 into 19 divided by 66. You can cancel, 2 1s are 2 33s are, 2 into 33s are, yeah. So 33 into 3 will be 99. 2 1s are 2 33s are. 33 into 3 becomes 99. So answer is 19 by 99. Hope it's clear. Make a substitution for t equal to 30 minus x power 3 by 2. Okay. Terms inside the bracket is t. So that when you differentiate this, I can get in terms of root x. Root x into dx is minus 2 by 3 dt. Correct. Derivative of 30 is 0. Derivative of x power 3 by 2 is 3 by 2 x power 3 by 2 minus 1. 3 by 2 minus 1 is half. Minus 3 by 2 taken, that's it, becomes minus 2 by 3. Minus 2 by 3 dt is equal to cross multiply root x into dx. Change the limits. When x is equal to 4, t equal to how much? When x is equal to 9, t equal to how much? So write in terms of t. T will be from 22 to 3. Okay. And numerator root x into dx is minus 2 by 3 dt. So minus 2 by 3 kept outside. Denominator is t square. Integral of 1 by t square minus 1 by t. Minus into minus plus 2 by 3. Integral of 1 by t square is minus 1 by t, minus into minus plus, evaluate the function upper limit minus lower limit, 1 by 3 minus 1 by 22. Take LCM, simplify, get the answer, 19 by 99. Next one, integral from 0 to pi by 4, sine cube 2t into cos 2t dt. Take the integral as I. The power of sine is odd number here. So we'll take t equal to, t is already present. So u will make a substitution. U is equal to cos. The power of sine is odd number. Put u is equal to cos function. The power of cos is odd number. Then put u equal to sine function like that. So there is a method actually. Whenever there is integral of the type sine power mx into cos power nx. There is a beautiful method. I'll explain all those things during synopsis part. Okay. So here put u is equal to cos 2t, and because the power of sine is odd number, put u is equal to cos 2t. Put u is equal to cos 2t. Differentiate this. Differentiate with respect to t. The original variable is t, no? So differentiate with respect to t. Derivative of cos 2t is minus sine 2t into derivative of 2t is 2. Correct? I need to find sine 2t dt. First I'll write one more step here. Integral from 0 to pi by 4. Okay. Sine cube I'll write. Sine square into sine. Sine square 2t into sine 2t into cos 2t dt. Like this I'll write. And I'll write sine square as 1 minus cos square. Integral from 0 to pi by 4. Using trigonometric formula identity, sine square is 1 minus cos square. So sine square 2t is 1 minus cos square 2t. Sine square 2t is 1 minus cos square 2t. Correct? Into cos 2t I'll write first. Then I'll write sine 2t into dt. Sine 2t into dt. So I put u is equal to cos 2t. Derivative of cos 2t is minus sine 2t into derivative of 2t, which is 2. So I'll find out what is sine 2t into dt from this. So from this du by minus 2. Minus to take this side. Minus du divided by 2 is equal to sine 2t into dt. Correct? Sine 2t into dt is minus du by 2. Change the limits. When the variable t is equal to 0. When t is equal to 0, u is equal to how much? T is equal to 0. When the lower limit t equal to 0, u is equal to how much? Cos of 2 into 0. 2 into 0, 0. Cos 0 is 1. Correct? When upper limit is t equal to pi by 4. When t is equal to pi by 4, u is equal to how much? Put t equal to pi by 4. 2 into pi by 4 is pi by 2. Cos pi by 2 is 0. Correct? Becomes cos pi by 2 0. Cos 0 1. So limits will change. 0 to pi by 4 becomes 1 to 0. 1 to 0. Limits from 1 to 0. 1 minus, what is cos 2t are taken? Cos 2t is u. Correct? U square. 1 minus u square. Cos 2t is taken as u. Correct? Sin 2t into dt is minus du by 2 according to this. Sin 2t into dt. Sorry. Du by 2 is equal to sin 2t dt, correct? This is sin 2t into dt. So sin 2t into dt is minus du by 2. Minus will keep outside. Du by 2. Minus half will keep outside, okay? Minus 1 by 2 will keep outside. Minus half is kept outside, correct? Minus du by 2 means minus half into du. Minus half is kept outside the integral. So integrate this and apply limits. Minus half into integral from 1 to 0. Multiply this u minus u cube, correct? U minus u cube. Multiply u inside. So we get minus half into integral of u is u square by 2. Integral of u cube is u power 4 divided by 4. Limits from 1 to 0. Correct? Integral of u is u square by 2. Integral of u cube is u power 4 by 4. So what we get is equal to minus half into. Evaluate the function at upper limit. Half into 0 square minus 1 square. Minus 1 by 4 into 0 power 4 minus 1 power 4. Like this we get. So this is equal to what we get. Minus half into. What we get is minus half plus 1 by 4. Correct? Minus half plus 1 by 4. Minus half plus 1 by 4 will be minus 1 by 4. So we'll get this is minus half into minus half plus 1 by 4 will be minus 1 by 4. Correct? Minus into minus plus. So answer is 1 by 8. 1 by 8 is answer. Multiply u inside, 1 into u square into u cube. Integral of u is u square by 2. Integral of u cube is u power 4 by 4. Minus half is kept as it is. Evaluate the function at upper limit. Half into u square. Half into 0 square minus 1 square. Minus 1 by 4 into 0 power 4 minus 1 power 4. 0 minus 1 is minus 1. So minus half here. Here minus into minus plus 1 by 4. Minus half plus 1 by 4 is minus 1 by 4. Minus 1 by 4 into minus half is plus 1 by 8. Answer is 1 by 8. With this, we have completed all the questions of NCERT exercise 7.8. Okay, and also the solved examples of NCERT book connected to that exercise. Everything has been completed. Method of substitution also we learn how to integrate by method of substitution if it involves a definite integral. So make a proper substitution. T is equal to or U is equal to differentiate with respect to the original variable, change the limits and then integrate and evaluate the function upper limit minus lower limit to get the answer. With this, NCERT exercise 7.8 has been completed. Okay, many more videos will be uploaded in the coming days in focusing on NCERT syllabus, both first PU and second PU, also NCERT exemplar problems. Each and every chapter we are going to solve completely. Okay, and KCT PYQs and JEE Main PYQs and synopsis too. Each and every chapter will be done. Okay, with this I conclude. Thank you.